This is an example of macro with keyword parameters. In the previous video, I have shown expansion of macro with positional parameters. So this is the second kind of parameter that a macro can have, and the name of the parameter happens to be a keyword parameter. Now a keyword parameter is represented by an ampersand followed by the name of the parameter, and then you have this equal to sign. So this equal to sign is an indication that the parameter happens to be a keyword parameter. And how do we assign values to this formal parameter? Okay, in the macro call, you're supposed to write the name of the parameter, the formal parameter, put an equal sign and tell us the actual value or give the actual value. So what it will do is it will search for a keyword parameter whose name is MV, and for that formal parameter it will associate this actual value called as A. So MV will be substituted by A. So if you look at the keyword parameter list in the prototype statement, where we have the name of the macro followed by 3 parameters, all 3 parameters are of the type keyword. Okay, you'll see that the first one happens to be MV, second one happens to be INV, and third one happens to be REG. But if you look at a macro call, the same order is not followed. Okay, now because it is a keyword parameter, the order in which you give actual values to formal parameters is not important. Okay, order does not matter, which is very important in case of positional parameters. Positional parameters take values based on the order in which they appear in the macro call. The same thing is not there, that constraint is not there in case of keyword parameters. You can call them in any order you want, because the macro processor would look at the formal parameter which is present on the left hand side of the equal sign, and to it would associate the value which is present on the right hand side, which would be the actual parameter. So you, in the macro call, the keyword parameters can appear in any order. Okay, so this here I have also taken a second macro called as simple, just to show you that if there were 2 parameters, then how the expansion would take place. Okay, so let's begin as to how the expansion for keyword parameter, a macro containing keyword parameters, would happen. So in the first case, we see that the macro processor sees that there is this keyword called as macro. So when it sees the keyword macro, so it identifies that a macro is present, and the first word following this keyword called macro would be the name of the macro. So what it does is it goes to this macro name table and says that I have found a macro and the name is INCR. Okay, then it will see that it has it look at the first parameter. Now the first parameter happens to be of type keyword, so there are no positional parameters at all, so the value #pp will be 0. One more thing what you need to know is that if there is a macro can have a combination of positional parameters and keyword parameters, and the author puts a constraint saying that if there is positional parameters and there are keyword parameters in your macro, then positional parameters should always occur before keyword parameters. So when we take an example of a mixed parameter list, we can see that positional parameters will occur before the keyword parameters. Right now this is an example for only keyword parameters. Right, so once it is identified that there are no positional parameters, this #pp value becomes 0. Okay, now the first parameter here happens to be of type keyword and the name is MV. Okay, so what it does is #kp will be incremented to 1, and then 2 entries are made. Okay, one entry is made in keyword parameter default table, and the second entry is made in the PN tab. So it looks, so it takes this MV, okay, and it places it over here. So we can write here as MV. Okay, and once we write that, it does it have a default value. This is the third kind of parameter, that is keyword parameter with a default value, which we have not taken. We have just taken simple keyword parameters, so there is no default value associated with MV, so this field remains blank, and we increment the pointer by 1, and then we take this parameter and we make an entry in PN tab over here. Okay, and then increment this pointer by 1. Okay, next it goes back and looks at the second parameter in this prototype statement. The second parameter happens to be known as INV. Okay, so when you look at INV, it is also a type of keyword parameter. So make an entry in the keyword parameter default table. So we will write here as INV. There is no default value associated with it, so we keep it as blank, and also make an entry in the parameter name table. Okay, and that is called as INV, and we increment this pointer by 1, and we increment hash KP by 1, saying that we found one more keyword parameter. Okay, next parameter happens to be of type keyword. Again, make an entry over here. This pointer has to be incremented once we write INV, which I didn't do, but it is done, and then we write the third parameter, and the third parameter happens to be register. It has no default value. We increment the pointer by 1, which will be 4, and then we make an entry in the PN tab also, that will be ampersand reg, and we increment the pointer by 1, and hash KP will be incremented by 1, saying that we found one more keyword parameter. Okay, after that there are no parameters, so we complete the remaining part of our MNT, that is there are no there are no expansion time variables. The current value for MDT, so if you look here, is 1. Okay, so it is set to 1. KPDPT is set to 1 initially, and SSTP is set to 1. Although we are not having any sequencing symbol tables, we are not having any sequencing symbols, we set the value as 1, and at the end of pass 1 we turn it to 0 if there are no sequencing symbols. But look here, the value of there are certain keyword parameters in our macro. So this KPDPT1 says that for the macro INCR, if you look at the KP tab, the keyword parameters begin from position 1, or begins from index 1. Okay, now once we finish this processing prototype statement, next we look at the statement called move R, register, and MV. So I told you, like how we do for positional parameters, the same thing is done for keyword parameters. We take it and place it into our MDT, so which is move R. Okay, and I mentioned before, okay, instead of writing the parameter, we will write a number associated with the parameter. Okay, so the first one happens to be register. Now go to your PN tab and see the number associated with register, which happens to be 3. So we write here P comma hash 3. Okay, now this 3 is not coming from the keyword parameter default table, but 3 is coming from the PN tab. Okay, after that we have MV. So please go to this parameter name table, and MV is at position 1. So how do we write it in MDT? We write it as P comma hash 1. That means we are referring to that parameter in the parameter table, which is placed at index 1. Then increment the pointer by 1. Okay, then the macro processor will go to the next line. It's a model statement. Okay, so we take it and place it into our MDT, which is add, register, and INV. So I will write here add. In place of register, I have to refer it by the index value. So register is in PN tab. If you look at it, is 3. Okay, and then it says about INV. Okay, so INV is nothing but at position 2. Okay, similar to the positional parameters that we did. Then the MDT pointer is incremented to 1. So the next we look at the next line, which is a move M statement, and register and MV. So we write it as move M. Okay, and register would be in PN tab. Register is at 3, so we write P comma hash 3. Okay, and then we write P comma hash. Okay, the parameter was MV, and MV in our PN tab is 1. So this is P comma hash 1. Okay, and we increment the pointer by 1. So once we finish this, Okay, once we have done processing of this, next we go to the next line, which is men, which indicates the end of this macro incr. So I told you that we do need to copy the men because it needs to tell us where one macro ends and the other one begins, because there is a possibility that more than one macro can be present in our program, which happens to be an example, which happens to be the case in our example. And there is a single macro definition table, so we need to keep track of where one macro ends. Okay, so once I have written men, I told you we have to do some processing with the MNT. Now to change this KP-DPT, we'll check whether KP value is 0. If KP value is 0, then this KP-DPT is set to 0. But in our case, there are certain keyword parameters, so this value remains the same. However, we are not having any any sequencing symbols, so STTP value is turned to 0. Okay, after that it goes to this next line and it says that there is another macro, and because it sees this keyword called as macro, so it identifies that there is one more macro present in our program. Okay, and it knows that the first word following this keyword macro happens to be the name of the macro. So what it does is it makes an entry into our MNT, and what is the name of the macro? The name of the macro is simple. Okay, next it looks at how many parameters it has. It has a single parameter. Okay, so that needs to meet, and the kind of parameter is positional parameter. Okay, so so this has to be entered into only one table, and that table is PN tab. Okay, so what you need to know is that a single PN tab is created. Okay, and that values are overwritten. So initially when we were working with macro INCR, we got these values as MV, INV and register. But when it went to the second macro simple, okay, the PN tab gets overwritten. So the PN tab actually becomes, there's a secret, I will differentiate them by PN tab 1, and this table itself, okay, gets overwritten. Okay, and it becomes a PN tab and the values for the second macro are written. So I will write it as PN tab 2. Okay, so we will just do this. Okay, I'll just copy this so that I'm able to enter the values. Okay, so all this will not be there for the second PN tab. Okay, so even it will not contain these parameters at all. Okay, and right, so this is PN tab 2, but actually there is no second table created. The PN tab 1 itself gets overwritten. Okay, and the values are placed over these values that are originally present for the first macro. Okay, just for understanding sake, I have created another table called as PN tab 2. Okay, so there is only one parameter, and that parameter is known as a positional parameter. Right, so we don't have to enter it into the keyword table. So what we do is I simply enter it into our PN tab. Okay, and increment the pointer by 1, and hash pp will be 1. Okay, and after that, if you look, there are no keyword parameters, so hash kp will be 0. Okay, hash ev will be 0. Okay, mdtp, now if you look at mdtp, go and see the current value for current mdt pointer value. So the current mdt pointer value is 5. Okay, so we write this entry as 5. That means the macro body of simple will be present from index 5 in your macro definition table. Okay, KP-DPT will be KP-DPT is whatever is the current pointer of KP tab. Okay, so if you look at the current pointer of KP tab, it is currently at 4, so it will be initialized to 4, and I told you SSTP will be set to 1. Okay, then we go and we place the body of the macro within MDT. So the first line here following this prototype statement happens to be called as print. So we go to this MDT and we start writing here print. Okay, and in place of F we are going to write P comma hash. Okay, what is the number? Because see here, look here, print ampersand F, go to our current parameter name table, and what we see is that F is at position 1, so we write it as 1. Okay, so this thing appears as 1 over here. Okay, we increment the pointer by 1. Okay, and after we have made that entry, we see that it's a mend statement. So please go and enter it into our MDT. So we will write here mend, saying our second macro ends over here. Increment the pointer by 1, which will be 7. Okay, and once we finish with that, go back and update your MNT. Since the number of keyword parameter was 0, there were no since the number of keyword parameters was 0, this KPDPT value becomes 0, because there are no keyword parameters for the second macro called as simple, and there are no sequencing symbols, so SSTP value also becomes 0. So we finished processing these two macros. Okay, there were two macros present, one containing keyword parameters and one containing positional parameters. The values are entered into MNT. Okay, a PN tab gets overwritten. Okay, I have just represented it by showing two different tables, but the original PN, there's only one PN tab which is getting overwritten. A keyword parameter default table is a single one. Okay, and then we have this MDT where the body of both the macros are present, and always the pointers are updated. Okay, and now the expansion part starts. Okay, so first, following this keyword mend, you've got this word called as start. So this start is compared with the name of the macro. So if you look here, the first name is INCR, there is no match. There is no match with simple also. So what it does is it writes that line as it is. Macro processor writes that line as it is. Next, it goes to this line called as ADS1. So it compares DS with INCR and simple. Again, no match occurs. So this line is written as it is. Okay. Now here, INCR makes a match with the first macro name called as INCR. So here this is a macro call. Okay, so this is a macro call and macro expansion should take place. So this line should be replaced by certain number of lines. Okay, so what it does is, first thing is it will set this MEC value. Okay, the MEC value is the MDTP value. So for INCR, the MDTP value is 1. So this MEC value will be set to 1. Okay, second, it creates an AP tab. Okay, to create an AP tab, I told you we have it will create based on how many values are there of the addition of hash pp plus hash kp. So if we are referring to INCR, so we add hash pp with hash kp, that is 0 plus 3. So this AP tab will have 3 values. Okay, because hash pp plus hash kp is 0 plus 3 is equal to 3. So an AP tab is created and this AP tab contains 3 values. So 1, 2 and 3. Okay, after that, okay, it says here register is equal to B register. Now how do we put these values over here? It is not directly put, so there is a formula over here. Okay, so that formula is happening to be this one. It is called as hash pp plus q plus minus kpdpt plus 1. Okay, so I will just show you for the first one how it works. Okay, so if I want to enter this B register in AP tab, okay, this B register should be associated with this register keyword parameter called as register. So what we are going to do, we are going to look at register in keyword parameter default table. That register is at position 3. Okay, so this Q value, okay, this Q value is 3 because in our keyword parameter default table, okay, register is appearing at 3. This is for register. Okay, so if I want to do for register parameter, okay, for register parameter, okay, for register parameter Q is 3. Okay, and we all know that hash pp is nothing but 0 in our case. Okay, so hash pp is 0, q is 3. Okay, this kpdpt is the pointer which is 1. This is all got from this table. Kpdpt is 1, hash pp is 0, but q is got from the kp tab. Search for register, look at the position which is 3, and that is why q is 3 and this is plus 1. So if you put it in that formula, so what will happen here is hash pp is 0, okay, plus q which is 3 minus kpdpt is 1 and plus 1. So this value happens to be 3. So what does this gives us? This tells us put the value of register. What is the value for register? B register. At which position? At position number 3 in AP tab. So at AP tab, I'm going to get this as B register. So this is the meaning of that. Okay. Now if I want to do for MV and A, okay, so where do I place it in our AP tab? For that, again, using this formula, okay, using this particular formula, so I will tell you for it's for MV, right? So for MV, okay, how do we get? I need to find hash pp. So hash pp is for this particular for this particular macro, hash pp is 0. Now q happens to be our entry in the keyword parameter default table. Okay, so for whom am I searching for? For MV. So for MV is at position 1, so q is equal to 1, and then comes kp dpt value, kp dp, then this keyword parameter default table pointer, which is 1, and I told you from where we get it, from our mnt. This kp dpt value is 1. So if I do a substitution here, okay, so this will be nothing but 0 plus 1, right, minus 1 and plus 1. Okay, so 0 for hash pp, q for 1, kp dpt is 1, and this plus 1 as it is. So this value turns out to be 1. So they are saying that MV should be entered, MV's actual value A should be entered at position 1 in our AP tab. So this turns out to be here. Okay, similarly you can do it for the next one, okay, which happens to be for INV. Okay, for INV parameter, again hash pp is equal to 0. Okay, what about q? What about q? Q is the entry in our keyword parameter default table. So what is that value over here? INV is at 2, so we write here as 2. Okay, then kp dtp is equal to 1. Okay, so this has to be in caps. Okay, so we write kp dtp is equal to 1. Okay, so this turns out to be hash pp will be 0 plus q will be 2 minus 1 for kp dpt and plus 1, which is the formula over here. Okay, so this value turns out to be 2. So I'm supposed to make an entry at position 2 in our AP tab, and what I'm supposed to enter is what is the actual value for INV, which happens to be P. So this is how the AP tab is filled for keyword parameters. The position depends upon this formula, hash pp plus q minus kp dpt plus 1. Q is the entry in the keyword parameter default table. Okay, now once we finish that, okay, what we are supposed to do, we are going to go to this MEC value. MEC value is 1, so go to line number 1 in MDT, take it and place it in the expansion. So this is move R. Okay, so here the line is, it's going to be move R. Okay, p comma hash 3. So that is what is written here, p comma hash 3 and p comma hash 1. The value at third position is B register, and the value at present, and the parameter value at position 1 in AP tab happens to be A. So we will write here as B register comma A. Okay, next what happens is MEC value is incremented by 1, so MEC value becomes 2. So go to the next line, this is add. Okay, it says p comma hash 3. Now please look at your AP tab, don't look at your PN tab. Okay, look at your AP tab, look at the parameter at the third position, which is B register, and parameter at the second position, which is B. So what you're going to write here is, you're going to copy that, add, okay, B register comma B. Okay, right, and then MEC value is incremented by 1, so MEC becomes 3. Go to line number 3, we have move M, so I will copy this move M over here. Okay, so this is what is happening in the expanded code. We've got move M here, and then it says p comma hash 3, which is B register in the AP tab, and p comma hash 1, which is A. So we are going to write here B register, okay, comma A. Okay, after that MEC value is incremented to 1, so this becomes 4. At 4 we've got M, called it as med. So we stop the expansion for INCR. Okay, now once they expand, these are the three lines that got substituted for this macro call called as INCR. Okay, after that we go to the next line. The next line also, if you compare simple happens to be a macro call because it matches this word under macro name in MNT. So what it does is it sets an MEC value. Okay, so it creates two data structures. The first data structure would be an MEC, so it says MEC, and for MEC it will look at this MNT table, so simple, and in MDTP it is 5. Okay, so MEC value is set to 5. Okay, this is set to 5, and after that it creates an AP tab. Okay, so it creates an AP tab. Okay, so if we look here, okay, so we've got another AP tab over here. Okay, and how many values? Hash pp plus hash kp values. So we will do that. Okay, I'll just write here number. Okay, and this is our actual parameter. Okay, actual parameter. Okay, how many values? Now which macro are we referring to? We are referring to simple. So hash pp plus hash kp. So hash pp plus hash kp is 1 plus 0, which is 1. So only one value is present in the table, actual, and we look at the macro call and we see that there is only one parameter. That parameter happens to be a. To put it in our AP tab in the order in which it appears. It's not a keyword parameter, it's a positional parameter, and in positional parameter they are placed in the AP tab based on the order that they appear. Okay, so here the entry is made. Then I will look at MEC value. So the current MEC value is 5. Go to the fifth line in our MDT. So it says print. Okay, so I'm going to write here as plus because it represents, it's an expansion, it has come from a macro expansion. So I will write here print. So if you look at the line p comma hash 1, so look at your current AP tab. This is our AP tab. So my current AP tab is this one, and it says p comma hash 1. So if you look, it says p comma hash 1, so which is over here a. So we have to write this as a. So this is how a comes over here. Okay, then MEC is incremented by 1. So initially it was 5, now it is 6. So go to your MDT and see that 6 happens to be met. So we stop there. Then we go to the line following this simple. So it's an N. This matches, tries to match INCR and simple. Match does not occur, and that's why it will write this end as it is and it will stop. Okay, so this is our expanded code where macro processor substitutes or macro processor handles this keyword parameters and makes the substitution and gives us this particular code, and this code is given to the assembler for further processing.